Hello, I'm Carly McAvoy talking about rational expressions, multiplying and dividing. What I have to do is factor, cancel, and then restate my answer. So I'm going to factor the numerator here. I have x minus 16x plus 63. I know that 9 and 7 add to 16 and multiply to 63, so x minus 9 and x minus 7. And then on the bottom, if I want to factor that, 45 is 9 and 5, so I have x and x, 9 and 5. I want those to both be negative as well. Then up here I have 25 minus x squared. That's a difference of squares, and that's going to be 5 plus x and 5 minus x. And this is also a difference of squares, x plus 7 and x minus 7. So once I've factored everything, I just cancel what I can. As long as one is on the top and one is on the bottom, they can be canceled. So x minus 9 goes, x minus 7 goes, and then x minus 5 and 5 minus x, those are opposites. And when I cancel opposites, I get negative 1. So I'm going to cancel that, but I'm going to get negative 1. So how I'm going to state the answer first is negative 5 plus x over x plus 7, which is a totally acceptable way to stop, but you could also say negative 5 minus x over x plus 7. Either one of those is okay. All right, let's look at dividing. When you divide, it's the same thing. You're going to factor, cancel, restate, except you have the additional piece of flipping and then multiplying. So I'm going to factor this 5 out, y minus 8 over 20. And if I could, I would have factored that, but there's nothing to factor. So I'm going to go ahead and flip that or find its reciprocal. And then I'm going to multiply instead of dividing. Now if I cancel, I can cancel the y plus 8s. I can say that 5 goes into 20 4 times. And that gives me 2 on the top and 4 on the bottom. And I could also say 2 goes into that once and into 4 twice. And now what I have is 1/2. So I can divide, and I always want to simplify until I can't simplify any further. One more of these. Remember, you can always pause and try these on your own and come back. 8x squared minus 20x, 5x squared minus x cubed, divided by, there should be a bar in here, 8x squared plus 4x minus 60, and x squared minus 2x minus 15. I'm going to take out the common factor. It looks like 4x, and that's going to leave 2x minus 5. If I was to distribute that back through, I can get what I started. And then I'm going to take out the common factor down here, which is x squared, and I'm going to get 5x minus, or I'm taking out x squared, so I just have 5, not x, right? And I have minus x, so 5 minus x. Because taking out the x squared, I don't have an x squared term left there. I'm going to go ahead and write this as a division problem again. I can take out a common factor of 4. That leaves 2x squared plus x minus 15. And I can factor that into x minus 5, x plus 3. The factoring is something that you just want to keep practicing on your own. I'm not finished factoring. I think I can factor this further, but I'm going to go ahead and rewrite the rest of it. And I have x squared and 5 minus x. And then I'm going to go ahead at this point and find the reciprocal of this and write x minus 5, x plus 3, and then I have the 4. I'm going to go ahead and try to factor this piece, which it looks like 2x and x, and I want 3 and 5. I want 6 minus 5. 2x squared plus 6x minus 5x is x, and 5 times 3 is 15. So again, factoring off to the side on your own time. You don't have to be as fast at that, but you should be able to get it factored. Now that we factored, we're going to cancel what we have in common. We have, what do we have here? We have 2x minus 5 on top and bottom. We have x plus 3 that can go. We have an x here that's going to cancel one of these and leave one behind. We have a 4 here and a 4 there. And then we have 5 minus x and x minus 5. Now those are opposites. X is positive, x is negative, 5 is negative, 5 is positive. What happens when I cancel opposites? I get -1. So on the top, it looks like everything is gone except for -1. In the denominator, I have x. So that's it, -1 over x. That's multiplying and dividing, mostly an exercise in factoring. Have a great day.